Right, more live coding of MazeRunner. Now last time I read the maze successfully and I started drawing it, but I ran into this problem. This is the maze I drew and the blue are the walls. And I expected to draw this top corner. So this wall is fine, and the one that goes down the side is fine, and the one that goes to the bottom is fine. But I expected the open spaces to start here at the top left, go down and right. And as you can see, that's not what is happening. They go down, but they don't go right. In fact, this seems to be upside down, or at least flipped. They go up and down. So I didn't tweak immediately what the issue was last time. And I stared at this code for a long time before I actually realized what was going on. But clearly there is some error in the code, because this maze is not drawn the way I expect it to be. So, where could the problem be? Well, there are only a few places where things could go wrong. We are either reading the maze incorrectly. So when we read the maze from the file, it is incorrect. That's one option. The other option is that we are drawing it incorrectly. So either when we access the maze here, we are using the wrong coordinates, or when we draw them on the screen, we are using the wrong coordinates. One of those three places. How do we find out which one it is? Well, we know what the file is, and we could actually, as we draw the maze, check which object we are drawing, wall or space. And I could follow along and see that it's drawing the right one at the right point. And that ought to tell me if I'm accessing the wrong element. So I expected to draw this, and then this, and then the next line. And if it's not doing that, I can stop it, and well, that'll tell me something. So how do we slow it down so we can see what's being drawn? Well, here I draw one square at a time, and when they're all done, I display the result. But instead of that, I'm going to display the result after drawing every single square. So after the switch, I draw one square and I display what's on the screen. And to make it even clearer, I'm going to add a delay of 1 second. So it'll draw one object every second. That should be slow enough for me to see what is actually going on. And it'll tell me if, well, it won't tell me if the maze is read incorrectly, but it may tell me if there's a mistake here or here. So I expect these to be drawn. Right, first, let's see what happens if we run this. It's the wrong one. What am I running? I want to run display. Okay. So now we actually can see exactly what is going on. It is drawing the maze correctly. It starts with the top line, and then it draws the next line, and then it draws the next line. But it draws it from the bottom up instead of from the top down. So almost nothing is incorrect except the y coordinate of the squares that I'm drawing. And that was because I started with row 0, thinking that's the top, then row 1, then row 2, then row 3, then row 4. And that was a natural assumption, because if you look at the maze, that is the row 0, row 1, row 2. But of course this coordinate is not 0. 0 is down here. And if I want to start from the top, I should subtract this coordinate for the very first square from the maximum to reflect it to the top. So the y coordinates I pass to standard draw should not be measured from here, but from the top, and that's an easy fix. We can do that easily. When I pass the coordinate to standard draw, this is the y coordinate, and I'm just going to say 7 times size, which is now getting a little cumbersome. Let's replace this with a constant as well. I'm going to call this the width. I know I already have a variable called width, which is the number of columns in the maze, but this width will be my screen width. Maybe I should call it S width. And it is 7 times the size of 1 square. And similarly, S height is 7 times, also 7 times this. They're the same value, but they might not be. I might decide to later introduce a horizontal width and horizontal, a vertical width, vertical height, and they might not. So I'm going to keep those like they are. This is going to be the screen width. This is going to be the screen height. Screen height is for my y coordinate. Screen width is for my x coordinate. And here I'm going to subtract the y coordinate from the screen height. Okay. And just once more, while this is being drawn slowly, or not at all, it's too much. I'm subtracting too much. I was sure this was going to work. Oh, that is the old y coordinate. And if I put parentheses around it, it would work, but I forgot to put the minus sign in there. Okay, that's just a small error. Okay, right, let's go again. That's why it took so long for anything to appear. That's okay, there we go. So just one last time. I was drawing the maze correctly, first row, second row, third row, but I was drawing them from the bottom. So this coordinate, let's say it's 10, 10. I should never have used 10, 10. If this total height is 500, I should have used 10, 490. So I just subtract the 10 from the 500 and I get the reflected coordinate at the top. And now my maze is correct. Now I can see that it's exactly the maze that I have in the file. So it's this top corner. I can see the open space. There we go. This is excellent. Okay. Good. So I am drawing the maze correctly, but now I'm going to change things somewhat. This is that top. Well, let's pick another corner so we can just verify that this is correct. I'm going to pick this spot, and now I have to count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's copy that. So 3, 3 was actually that center coordinate, but now I want to draw this one, so it will be 15, 3. Okay, right, let's do that. Stop that program and delete that line because it'll cause problems, and take the show out back out. No delay. And here I want to draw 15, which is my x coordinate, and 3, which is the y coordinate. Okay, right, and yeah, I think this is correct. Let's just compare. So this wall is this wall, and here is the space coming around like that, and there's the space coming around like that. And on this side we have kind of dead end that goes off in that direction. We can see this corner over here, and we can see this corner, it's down here. Okay, fine. So I'm drawing the maze correctly. But Let me just quickly change this back to 3, 3. There's an issue, and that is that I was drawing 3, 3, and it's actually this cell, which is right in the center of my display, and that's fine, hunky-dory. What if the player was over here, and I wanted to draw this cell? Well, this cell would then be located where this one is now. So this space would be here, that's fine. The blue wall would come around here, and that's fine. But what would be above the blue wall and on the left-hand side of the blue wall? Well, you could say nothing, or I could make a special case. But the fact is that if I try to access the maze array, these positions don't exist. That's maze 1, 1, that's maze 0, 0, and the square that's out here simply does not exist. So what I'm going to do is I am going to artificially, when I read the maze, I'm going to add 2 rows to the top, 2 rows to the left, 2 rows to the left, 2 at the bottom, and 2 on the right, so that there'll be a buffer around this maze, so that if the cell happens to be in the middle, I'll see the buffer walls that I've added. And then I don't have to change anything else in the program. I don't have to have special cases to check, is the coordinate I'm trying to do actually outside the maze, any of that. So we'll have to change read maze a little bit, and I'm going to change width and height also. So let's see what's going on here. I read the height. I'm going to add 2 at the bottom, 2 rows at the bottom, 2 rows at the top. So that's 4 in total, if I can type correctly. And this will be 4 as well. I'm going to initialize them shortly. In fact, I'll do it here. Right in here. If h is less than 2, so I'm dealing with row 0 or row 1, then this is definitely a wall. It doesn't matter what is in the file, and I won't even be reading the file. Then this is definitely a wall. Else, I'm going to read from the file, but this only adds the top 2 rows. So I'm going to add to this condition here, if h is less than 2, or h is one of the last rows, so that's greater than or equal to height. The last row is h minus 1, the second last row is, height minus 1, the second last row is height minus 2. So if h is greater than or equal to height minus 2, or if w is less than 2, it's on the left, or, so that's w0 or w1, or w is greater than equal to width minus 2. If any of these 4 conditions are true, or even more than one of them at a time, then I'm dealing with a wall. Otherwise, read the next character and put it in the maze array where you need it. And I've already I've added some height and width to the array, to my height and width variables, so that I can accommodate for that. And the only tricky thing now is that 3, 3 is no longer in the corner. I've got to say 0, 0. Wow. No, 3, 3 will be the 3, 3 will be the corner cell. I think we should see the corner. Because if I put a 0 in there, x is going to be 0. C will start at 0. C plus x minus 3 will be 0, plus 0 minus 3 will be minus 3. So these x and y coordinates can never be less than or equal to 2, and they can't be greater than or equal to width minus 3, or yeah. Cool. I think I've got that. Maybe I make a mistake and I will come back to this. Okay, right. So this is the very corner of my maze, and it is correct. And here, you can't really see it, but these are the rows that I have added artificially, artificial padding. I've got 5 minutes to go. I quickly want to work the keys into this whole thing, but to start with, I am quickly going to add the green player in the middle, and I'm going to cheat a little. So before we draw the player's position, player is right in the middle of the screen, so it's 0, 1, 2, 3 is in the middle, 4, 5, 6 on the side. So 3 on that side, 3 on that side, and 3 is the middle of the screen, or the window, the grid, the little viewport that I'm looking at. I think that's correct. We'll see in a sec. Yes. So green will be my player, and I want to move the player around. So he needs coordinates. And I am, instead of this being 3, 3, I'm going to give my player some coordinates. Player X is 3, player Y is 3. And now I'm going to basically steal code from the short video about checking for key presses. So I think we had a while through, because it runs forever. Now, first step is to display the current frame. And yeah, let's display the current frame. And now we did a check. If standard draw dot is key pressed, and if you haven't seen it yet, go look at that video, because it explains that we need to use key event dot vk down. And the key event needs to be imported. Control space key event. Okay. vk down, I need to increase y. And of course this isn't 3, 3, because it will be displaying the same point every single time. Okay, else, let's do it like this. Else, if it's up, then y will be decreased. And I need a left. X will be, player X will be decreased. And I'm just going to take this away. Click there. If it's right, then X will be increased. Now, if you watch that other video, I had a standard draw dot show 10, I think here, which means this loop will delay 10 milliseconds and it'll execute 100 times a second. And now show appears here in this loop, but also inside display maze. So I've changed my mind. I'm going to take it out of display maze. I'm going to delete that. I'm just going to have it here. And the other program showed a ball animation, but there I wanted the animation to be quick because I wanted to see the ball move smoothly. Here nothing's going to change really. There's no animation going on. So I think I can wait a little longer. I'll wait 200 milliseconds. So this is going to execute 5 times a second. It's also going to check if a key is being pressed 5 times a second. And in the other program, I had a special counter that avoided the checks, so that they're not checked 100 times a second, but only 4 times a second. But I think 5 times a second is fine, and I think this will be fine. I'm going to save that. So what am I doing? I'm keeping track of where the player is in the maze. I display the maze for those coordinates. Then I check if a key is being pressed, and if it is, I change the player position appropriately, and I read and I display the maze with a short delay. So I'm going to run this, and I'm going to see if I actually can move around. I can, but it's not very responsive. So if I just miss, if I press the key and I just miss the check, because remember it's waiting, you can't see where I'm pointing, but it's waiting for 200 milliseconds right here. So if I press the key during those 200 milliseconds, it's going to miss it. So I can't make this big. It'll have to be much quicker. And let's just hope we don't see any flicker. Oh, too quick. No, it's too responsive. 10 times a second. How long do I press a key for? Yeah, 10 times a second should be fine. It's still not perfect, but we'll fix that soon. The only issue is that you may have noticed in my last run that it's not checking for walls. So I can actually at this point move through the walls. It just moves the maze, moves the player inside the maze if I press the right keys, but I can imagine that I'm playing this game. Move around. Ooh, through the wall. Next time we'll check for wall collisions, that the player can't move into a wall, and we'll add some nice graphics.